Okay, we will now start the notes for Chapter 4. You are going to find that Chapter 4 is full of definitions, and there is a lot of writing to do in this. And we don't have a lot of time, so I'm going to be moving fairly quickly, so do your best to try and keep up. So let's get right into it here. The first definition is for a simple random sample, or an SRS, and this is what I have for my definition. Every group of individuals has an equal chance to be selected. And this is the most common type of sample that we take in statistics. And we've done many examples, but generally, when you're selecting an SRS, you are going to be either using a table of random digits or a random number generator on the calculator in order to find your SRS. So I'm just going to say for the example that you want to use a table of random digits. Okay, the next definition here is for a stratified random sample, which is fairly similar to an SRS, but there's one difference. To begin with, you will take your group of all of the individuals and you will separate them into groups. So I'm going to say here, separate individuals into groups. And another word for groups is strata, and that's where the term comes from. Now once you have them separated into groups, you then choose an SRS from each group, or from each strata, I'll say. So the classic example that I gave in class for that one was if we wanted to take a sample at East Kentwood High School, but we wanted to be sure that we had a certain number of freshmen, sophomores, juniors, and seniors represented, we would first split the whole population into freshman, sophomore, junior, and senior, and then select a random sample within each strata. So I'm just going to write down freshmen, sophomore, juniors, seniors as our example for a stratified. Now, a cluster sample is different than a stratified random sample. So here's how a cluster sample works. You're first going to separate individuals into groups or clusters, but this time each cluster represents the whole population. Okay, so each cluster has to have an accurate representation of all of the people in the population. Now once you've chosen all of these clusters that you have, where each cluster individually represents the population, you will then choose an SRS of clusters and select all individuals in those clusters. So once you've selected a cluster as part of your sample, you will then sample every individual within that cluster. So the example for that was kind of harder for us to come up with in class. But I think what we decided on was that if we wanted to do this for East Kentwood High School, we would have a homeroom, and in every homeroom there would be freshmen, sophomores, juniors, and seniors. So each homeroom individually is a cluster which accurately represents the whole population. And then we would select an SRS of 5 homerooms. And for each of those homerooms that we selected, we would sample all of the individuals within each of those homerooms. So sample all individuals in selected homerooms. Now, to me, one of the best ways to keep all of these samples in your mind is to think about the river problem, because the river problem is really a good example of all 3 of these different types. Now, just to remind you of how this problem worked, there was a river, and then there's some land next to the river, and it was set up into 16 different plots. So we numbered the plots. 1, 2, 3, 4 in the first row, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are the 16 plots of land. And remember that the yield, the amount of corn that we get out of this land, of course, is going to depend on how close it is to the water here. The closer it is to the water, the better the yield is, because the soil is better. So let's talk about each of the three different types of samples here. If we wanted to do just a simple random sample, then what we would do there is we would randomly select, and let's say we wanted to pick 4 plots of land. We would randomly select 4 of the 16, using a table of random digits or using a random integer function on the calculator. That is a simple random sample. Now the problem with that is that the 4 that get selected could be the 4 that are very close to the river, or the 4 that are far away from the river. So that may not be the best approach here. So what we then looked at was the idea of a stratified random sample. And first we had to decide how we were going to stratify it, by row or by column. And what we decided was the best way to stratify was by column. So we created 4 columns. Each column represented a strata. And then within each strata, we randomly selected 1 out of the 4 plots. Okay? So we would randomly select 1 in each column. Now the advantage to this is that you will definitely get one that is close to the water here. Definitely get one that's a little further, and one that is far away from the river. So you are guaranteed to have one that is at each level. Now the other way that we decided that we could have done it is using a cluster sample. And the clusters would be the rows. So let's say cluster equals row. And what that would mean is that each row is a cluster, and each cluster accurately represents the whole population, because that row has a plot of land close to the river and a plot of land far away from the river. So the way that we would do that is we would randomly select 1 cluster, or 1 row. And then within that row, we would sample all 4 within that row. So sample all 4 in that row. So anytime you're having trouble differentiating between those 3 different types of sampling, try to think back to the river problem and what we did on that problem. Okay, so some more definitions here. We are now moving into poor sampling techniques. And the first one listed there is voluntary response. And for my definition on this one, I simply wrote respondents choose themselves. And the example that I always think of for this is a call-in poll, where they ask people to call in. And the issue there is that the people that tend to call in are the ones that feel strongly on the issue, and therefore you get a biased sample that's not representative of the whole population. So the next one we have there is a convenience sample. And for my definition on that one, I wrote sample respondents who are easy to reach. Okay, easy to reach. And the example I'd like to give for that one is taking a sample at the mall. So you go to the mall that's closest to you, it's very easy, it's very convenient, and you just sample whoever you may see walking around the mall. That is definitely not going to give us a representative sample of the whole population, and is therefore a poor sampling technique. Okay, so let's move to sampling errors, which of course occur during the act of choosing the sample. And the most classic example of that is the undercoverage. And for this one, some groups of the population are systematically left out of the sample. okay, systematically left out of the sample. And the example that I like to use in my mind for this one is that sometimes they will take samples using telephone numbers, and of course, the people that are left out of that sample are the people without phones. So they are undercovered. So we'll say people without phones are undercovered. Okay, now let me move to a new page here, and we'll get to the non-sampling errors, which of course have nothing to do with choosing the sample. They're present even in a census. So remember that these terms are referring to situations where the sample has already been selected. Okay, and that's why it's a non-sampling error. So for non-response, a person who was chosen as part of the sample cannot be reached. So maybe it's a telephone poll, and somebody gets selected to be part of the sample. They call them, and for some reason they don't answer the phone. That would be non-response. Now, response bias is when the respondents who were chosen to be part of the sample, the respondents give false information. Essentially what we're talking about here is when people that are selected as part of a sample lie about certain information, okay, for whatever reason. And then the next one is the wording of the question. And we've seen this many times before where questions have a particular agenda or a certain response in mind. So I just wrote down here questions written with certain responses in mind. Okay, now the next big distinction that we have to be able to make here is the difference between an observational study and an experiment. And this is definitely an idea that shows up on the AP exam, both on the multiple choice as well as the free response. But in general, an observational study simply observes individuals and measures variables. Whereas an experiment, we know that a treatment is imposed. Now, of course, the advantage of an experiment over an observational study is that we can show causation. Okay, that is the advantage of the experiment over the observational study. Okay, so go ahead and flip to the next page there. And of course, more definitions here. So we are going to look at some definitions for experiments, starting with experimental units. And the experimental units would be the individuals on which the experiment is conducted. And sometimes this can be people, but sometimes your experimental units could be something like plants. Okay, like the Wisconsin fast plants could be our experimental units. Now the treatment is the condition applied to the experimental unit. Or I guess we could say the condition imposed on the experimental unit. And then the factors, well, those would be the explanatory variables. And sometimes there's only one explanatory variable, and sometimes there are many explanatory variables, so you can have more than one factor in an experiment. Okay, so let's talk about the three principles of experimental design. Number one is to control the effects of lurking variables. Number 2 is randomization, and the words that we like to use is, we like to say random assignment. And I guess I'll say random assignment of treatments. And then the third one is replication using larger sample sizes. Okay, so another definition here. Block design. This is definitely one that will show up on the AP exam, a lot of times in a free response question. So the way a block design works is that you first separate individuals into groups. And we could call these groups blocks, of course, and that's why it's called a block design. And then you randomly assign treatments within each block. Now this sounds very, very similar to a stratified random sample where we first separate individuals into strata and then take a random sample within each strata. The difference here is that a block design is for an experiment, whereas a stratified random sample is for a study. Now for an example of this, let's say that we are talking about the effects of aspirin on headache relief, and we think for some reason that men and women would behave differently when given the aspirin. So what I'd like to do is actually draw an outline of this situation here. And this is an outline that you could use. You could use this type of response in a free response. So here's how it works. Let's suppose that we start out with our experiment and we have 100 experimental units. So 100 people sign up to be part of this headache study to see if aspirin will improve headache relief. Now, for some reason, we think that men and women will behave differently. So we are going to first take our 100 experimental units and split them into 2 blocks, men and women. And let's say that it was an even 50-50. So there were 50 men and 50 women. Now, one thing to remember here is that we did not use random assignment to split people into men and women. Okay, that is not where the random assignment occurs. That occurs in the next stage of the experiment, where we look at the 50 men and we use random assignment to give them a treatment. So we will randomly assign them to either be taking aspirin for headache relief or a placebo. And we would like these 2 groups to be the same size at 25 and 25. Now, of course, we would do that with the women as well. And once again, we are using random assignment here so that we can randomly assign the treatments. So we'll put 25 in each group. So once we have assigned the treatments, we will then measure some response variable, and we will compare. But you need to tell me what it is that you are comparing. In this case, we will be comparing pain relief. And we will do this individually within each block. So important things that you must include in this outline, if you're going to use this outline, is you definitely need to use your numbers to tell me how many experimental units are in each group. You definitely need to show that you are using random assignment. And then in the end, don't just say compare, make sure that you tell me what it is that you are comparing. Now, if this was a free response question on the AP exam, they would also ask you how you would randomly assign the treatment. So really they're asking you, how did you do this random assignment here? So here's how you would write it out. I'm going to talk about how we would do it for the group of 50 men, and then of course it would be the same for the 50 women. So the first thing that you would do is you would label the individuals. In this case, we're going to have to use 2 numbers. So I'm going to say 00 to 49. Then you would use a table of random digits. Two at a time. Okay, we're looking at 2 numbers at a time. We should say that. The first 25 numbers to appear And of course we are ignoring some things here. We will be ignoring the numbers 50 through 99, and we will also be ignoring repeats. And we need to say that. So the first 25 numbers will be given aspirin, and the remaining individuals get the placebo. Now this is how we would randomly assign the 50 men into the two treatment groups. Of course, we would do the same for the 50 women. You do not have to describe it a second time. Okay, on the AP exam, describing it once is enough. Okay, last thing on here, the scope of inference. So if we're talking about scope of inference, it says if the sample selected is truly a simple random sample, then the results can be generalized to the population from which the sample was taken. Okay, the population from which the sample was taken. And then the last thing, if an experiment randomly assigns treatments to subjects, then the results can show cause and effect, which of course is the goal of an experiment, is to show cause and effect. Okay, so remember, tomorrow you will be taking your first quiz on chapters 1 through 4. I will tell you right now that the quiz is composed of 14 multiple choice questions and 2 free response questions. So make sure that you study your chapters 1 through 4. I would suggest looking back through your tests, chapters 1 through 4, to help you get ready for tomorrow's quiz. Good luck and have a good day.